Using molarity to find solute mass and solution volume. So there's a couple of different variations on this question. So the main thing to remember is the relationship that concentration, if I can spell it, is in moles per liter. Okay. So that is given to you by dividing the amount in moles by the volume in liters. So if you know two of those things, you know the third, right? You just might have to rearrange and calculate. So there's one thing that's going to help you out. The other thing is if you have to calculate your solute mass, well, if you've worked out the moles of solute, so that is this guy right here, so you'd rearrange and solve for your amount in moles. So that's your concentration in moles per liter times your volume in liters. We know how to convert amount in moles into mass in grams because you're just going to use the molar mass. Okay, so in this case we have been given our volume, we've been given our concentration, and we're asked to work out our mass in micrograms of zinc oxalate. Ooh, this is a juicy one because we've got some unit conversions here. So this is M is always milli, so milli means 10 to the minus 3, okay? So we're going to have to convert millimolarity into molarity, as well as converting mass in grams into micrograms. And remember, micro is that little mu symbol, which kind of looks like a squiggly U. So remember, micro, if I can draw this thing. Come on, let me draw it. No, that's not the right thing. That is not the right thing at all. Give me a squiggly line. Squiggly, squiggly. There we go. Micrograms is like the little U with a little thing on the front, right? Something like that. Okay. And that is 10 to the minus 6. So our plan then is going to go from our concentration, which is in millimoles per liter, and we are going to want to get to, well, our concentration in moles per liter, I suppose, because we're going to want to do that little SI unit conversion there. And then we should be able to use our volume to get to our amount in moles. So again, we're going to have to convert milliliters into liters in there, so 2 steps. And then if we got our amount in moles, we can get to our mass in grams using our molar mass. So I don't know why I just did spaces instead of just drawing some arrows in there. I don't know. It's I guess it's just going to be one of those days where I have to do things the difficult way. Who would have thought? Okay, so what are we going to have to gather to be able to get from here to here? Well, millimoles to moles per liter. We know that 1 millimole per liter, 1 millimole is going to be 10 to the minus 3 moles. So that's going to be our conversion factor there. And our volume that we're using is 350 milliliters. And we're going to have to, so we'll have to divide, sorry, we have to multiply by the 350 milliliters, and then we are going to have to use unit conversion to convert between that 1 milliliter is 10 to the power of minus 3 liters. Okay, so then we'll have our amount in moles. So we're going to use our molar mass of our zinc oxalate. So I guess I should calculate that really quickly. So the molar mass of zinc is 65.39. 2 carbon, so 2 times 12.011. 4 oxygen, so 4 times 15.999. All right, so let me just type that in really quickly. You can see I am still in my favorite football stadium. I can see the Lyndhurst stand in the background, which was always a stand that I used to go to. 153.408 grams per mole. The finest pitch in the UK, apart from Wembley, as my dad used to say. Right, so the concentration in millimoles per litre then is 6.1 times 10 to the power of minus 5 millimoles per litre. Okay, so it's starting with there. So then we're going to want to convert it into moles per litre. So we're going to want to use that every 1 millimole is 10 to the power of minus 3 moles. Okay, so we're getting somewhere right there. Okay, I'm just going to make this get out of the way. See some more of that fine turf. Okay. I've just remembered also there is one thing that I did not put on the end here, which is that we aren't asked for the mass in grams, we're asked for the mass in micrograms. So I'm just going to put that up there right now. I'm just going to use a U, okay, because it's easier for me to type. And we know that micro means 10 to the minus 6. So 1 microgram is 10 to the power of minus 6 grams. So we're supposed to know all these by now. Right. Okay, so right now my millimoles is cancelling out. I guess I might as well show that, seeing as I've already lost my text box. So, right, we've converted our concentration into moles per litre. Sweet. So now out of that, we have to get our amount in moles. Okay. So to get rid of that per litre, then I'm going to just times by the volume, which is 350 millilitres, but that's not compatible with a litre. So I have to convert millilitres into litres. 1 milliliter is 10 to the minus 3 litres. Okay. So as of right now, my millilitres and my litres will cancel out, giving me my number of moles of zinc oxalate. Okay, so I've got my moles of zinc oxalate now. All I'm doing is something we've been doing for ages now, which is converting amount in moles into mass in grams using the molar mass. So we know the molar mass is 153.408 grams for every 1 mole of zinc oxalate, like so. Okay, so now the moles are going to cancel out. And then last of all, I have to convert mass in grams to mass in micrograms. So we know that 1 microgram is 10 to the power of minus 6 grams. Okay, so it's a feast of unit conversions today. All right, so let's stick it all in my calculator and see what we got. Da-dum, da-dum, da-dum. 6.1 times 10 to the power of minus 5 times 10 to the power of minus 3 times 350 times 10 to the power of minus 3. Yep. Okay. Times 153.408. All right. And then divided by 10 to the power of minus 6. Boom! 3.27 blah 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 micrograms, and we're asked for 2 significant digits, so that 3.2 is going to round up to 3.3. There you have it. Okay, so that is finding solute mass from molarity. Okay, so I want to find one where we've got a solution volume as what we're going to have to find. Mass in kilograms. Oh, another little unit conversion for you guys to play with. Volume in milliliters. Here we go. All right, so let's see what we have. We're asked to calculate the volume in milliliters of a 3.6 molarity sodium nitrate solution that contains 150 grams of sodium nitrate. So let's make a plan. Okay, we've got the concentration of the solution, so that gives us moles per liter. Okay, we've got the mass in grams. Okay, so we can get from the mass in grams into the moles. So before we do anything, we should get the molar mass of sodium nitrate. So that is going to be sodium is, oh no, my periodic table went away. There it is. Okay, so sodium is 22.990, I think. So 22.990 plus nitrogen, which is 14.007, plus 3 times oxygen, 3 times 15.909. So what is that going to equal? Come over here, you. All right, so 3 times 15.999 plus 14.007 plus 22.990. Okay, so that gives me 84.994 grams per mole. So remember, if you get a little bit stuck with the mass to moles and blah, 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 you know, you can always rewrite that as an equivalency. So for every 1 mole of sodium nitrate, that is going to be a capital N, please, exactly 84.994 grams. Okay, so then we've got to look, we've got 3.6 moles per litre, and I now know if I got my 150 grams, I know how many moles I've got, right? So let's convert 150 grams into moles. So we're going to go mass to moles of our sodium nitrate, and then we can use our concentration as a conversion value to get to our volume, and that is going to be in liters. So then we're going to want to get to our volume in milliliters. So that's my kind of mental plan for what we're going to be doing here. Okay, so our mass is 150 grams. Use the molar mass, 84. 0.994 grams for every 1 mole of sodium nitrate. Okay, we know this concentration of 3.6 molarity. If you want, write it out as an equivalency. So 3.6 molarity means that there's 3.6 moles of sodium nitrate for every 1 liter of solution. Do it, if that helps, okay? Because now it's really obvious what I've got to do here, that I can write 1 liter on the top and 3.6 moles of sodium nitrate on the bottom. So what I'm essentially doing, that you may have learned before, before using dimensional analysis for everything, is that, you divide by the concentration, right? So look, if you rearrange this and made volume the subject of the equation, you take amount in moles, divide by concentration in moles per liter. That's exactly what we're doing here, okay? So now I can see that my mass in grams cancels out to give me moles of sodium nitrate. My moles of sodium nitrate cancel out to give me my volume in liters. So now all I've got to do is get to my volume in milliliters, right? That's easy, because I know milli means 10 to the minus 3. So 1 milliliter, oh my gosh, is 10 to the power of minus 3 liters. That's all I got to do to get to my answer then, because I can see that the liters is going to cancel out. It's going to give me my volume in milliliters. Not as tricksy as I thought it was going to be, right? So mass to moles, 150 divided by 84.994. Okay, then divide through by that 3.6 moles. Okay, and now I've got my volume in liters, so then I'm going to, liters I'm going to convert into milliliters. And that should give me a 490.23 blah 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 milliliters. Okay, and we're asked to 2 significant digits. Oh, ALEKS, you fiend. So if I write 490, that is technically 2 significant digits, although it's a little ambiguous. So I suppose what you probably should do is write 4.9 times 10 to the power of 2 milliliters to be absolutely unambiguous about that, right? So if you're not sure with sig figs, standard scientific notation's always a win, right? So technically that, oh, go away, text box. Technically this is 2 significant figures, right? ALEKS is a little bit fussy, right? So it makes you put the decimal point, right? So I would default to this one. All right, so get some practice with that, okay? The more you do, the easier it gets.